Hello students, today's topic is Aryl Halide conversion tricks to different organic compounds. Aryl halide, now we have taken chlorobenzene with a 3 lone pair of electrons on chlorine. Lone pair of electrons undergo resonance through benzene ring to create delta negative charge on 2, 4 and 6. It promotes electrophilic aromatic substitution, which is known as orthopara directing, but plus M effect for orthopara directing, again minus I effect, inductive electron withdrawing effect from benzene. It is deactivating. Orthopara directing and deactivating, it relates ESR, electrophilic substitution reaction. Now, first reaction is chlorobenzene or bromobenzene to Grignard reagent. In magnesium ether dry condition, it is converted to phenyl magnesium bromide or phenyl magnesium chloride, which is known as Grignard reagent. Grignard reagent is a very important one to generate other organic compounds. Next one is chlorobenzene with methyl chloride in presence of sodium in again dry ether. There are 3 types of reaction. One is urge for both are aliphatic. Only alkyl halides are there to form alkane. Next one, urge phytic. One is aliphatic, another is aromatic. Urge phytic, ARX plus RX. Next one is phytic only in presence of ARX. Number 2 reaction is urge phytic. Chlorobenzene and methyl chloride in presence of sodium to give toluene after the release of twice NaCl. Number 8 reaction is chlorobenzene along with chlorobenzene, both are aromatic in presence of sodium in dry ether. It is known as phytic reaction to form diphenyl after the release of twice NaCl. If iodobenzene is used instead of chlorobenzene or bromobenzene in presence of copper in dry ether, it forms again diphenyl in Ullmann reaction. Then there are 3 types of reaction. First one urge phytic, second one is phytic, and third one is Ullmann in case of aryl halide to convert methyl benzene or diphenyl system. Number 3 is normal reduction to replace chlorine by hydrogen to give benzene. Number 4 and number 5 both are electrophilic aromatic substitution. Chlorine is orthopara directing as discussed previously due to plus M effect, due to presence of lone pair plus M, or it is also known as EDG, electron donating group. Then next chlorine in presence of chlorine in Fe dust or any other Lewis acid catalyst, orthodichloro and para-dichloro. Para product is more than ortho due to steric repulsion in ortho. Again, para product is more than ortho in case of sulfonic acid, orthochlorosulfonic and para-chlorosulfonic acid. Both are chlorosulfonic acid. Chlorosulfonic acid. Next one, CN minus attack on chlorobenzene, but due to partial double bond character in carbon chlorine in chlorobenzene, it requires high temperature 475 Kelvin to replace chlorine. Again, another one is in which in presence of any which solution in presence of chlorobenzene, it requires again higher heat to replace chlorine due to partial double bond character in carbon chlorine to form the phenol, first one sodium phenoxide, and then by using dilute HCl it is converted to phenol. It is also known as Dow process. Again, in state of magnesium, if you put lithium in dry ether, it forms phenyl lithium, which is acting as strong base. Ammonia can replace chlorine to form aniline aryl amine, known as aniline, by nucleophilic substitution. If you put nitro group in 2,4,6 position, then chlorine replacement is much more easier than the previous one. It is a very special type of case in which para position is activated to replace the water, 2 chlorobenzene and 1 chloral. Chloral is a trichloro derivative of acetaldehyde. H2SO4 is used to remove H2O from the system to form DDT. DDT is widely used as insecticide, dichloro, diphenyl, trichloroethane. First one, phenyl magnesium chloride or bromide. Iodide reactivity is higher than bromide and then chloride due to bond length issue. Iodide is longer in bond length, bromine is shorter, and chlorine is again shorter. Next one, free radical mechanism is there. Free radical mechanism in case of Urch-Fittig, in case of Fittig also, and also for Ullmann reaction. Third one is normal reduction to form chlorobenzene to benzene. 4 and 5 both are electrophilic aromatic substitution, ESR. Next one, nucleophilic substitution, NSR, to form cyanobenzene. Next one, phenyl lithium is formed by using lithium in dry ether. Next one, Fittig and Ullmann reaction. Number 9 is using ammonia to form aniline, and Dow process is involved to form phenol. Water removal from the chloral by using chlorobenzene to form DDT. These are the main reactions involved in chlorobenzene or aryl halide to form other organic derivatives or other organic compounds from chlorobenzene. Thank you.